All right. Hello, everyone. Welcome. Let's go ahead and get class started. Just real quick before we begin, just want to remind you all that next time we meet on Tuesday will be our next in-class assignment. The good news is that it's over what we're talking. Okay, so I'm glad you're all here today. You will get all the information you will need to complete the next in-class assignment over the next hour and 20 minutes or so. Hopefully, that's the goal anyway. Um, we're also going to be doing some coding stuff today, and actually, specifically, we're going to be talking about tests, unit testing, test-driven development, stuff like that. It's a very important topic. Tests, I think, are oftentimes overlooked. People don't always necessarily like talking about tests. Let's start by chatting about, what students' usual exposure to testing looks like. I don't teach every class here, obviously, but I definitely use unit testing in some of my classes, including the intro class. And most of the time, what that looks like is me giving you all, the students, a big old pile of tests and then saying, here's a homework assignment. Your goal is to write the code that's going to make all the tests pass. And that's not necessarily a bad. I think it's actually there's a reason why we do it that way, right? That's a pretty uh, accurate reflection of what we're trying to do in practice when we're making code to be used out in the world. But why? Why is it so important to have those tests? And consider that if we have a big old pile of code, we need to be able to demonstrate that it does what it's supposed to. That's really what the tests are for, is to verify that yes, this code actually will do what I tell you it's going to do. So yeah, giving me an application saying it does X is only so good. If you have a bunch of tests that prove that it can do X, that is a much better situation to be in. Another reason why testing is so important, and this is something that I think is not something that a lot of students get exposed to in class. Consider working on a project over a long period of time. You're going to be adding new things to that project, and it's very possible that some of the things that I add to that project breaks some of the old stuff that I wrote months ago or even years ago, right? That's very possible. So having tests is very important in that situation so that I can verify, oh, I just added this new feature, I just added this new code, just added this new functionality. Let me rerun the tests and make sure that by adding this new thing, I didn't break all of the other stuff in the process. So having those tests is a pretty crucial part of coding. Let's talk about where they come from, because this is, kind of back to the unrealistic example that you all get exposed to when you're taking classes here. I think most of you are probably used to what I described earlier, where someone, usually me, the instructor, gives you a pile of tests and says, write the code that's going to pass these tests. But where do those tests come from? Obviously, I write the tests for my classes or get help writing tests for my classes. But if you're working at a job, if you're working at Google or at Microsoft, your boss or someone isn't going to come and say, hey, here's all the unit tests for that thing you have to do. No, actually, you're going to have to write the unit tests for the thing that you are working on. So getting practice doing that, getting used to writing unit tests, how do we write unit tests, I think is very, very important, very underrated skill, very, very necessary one. And I'm going to take that one step farther and encourage you all to, you know, get comfortable with the idea of writing our tests first. I think it's easy to get comfortable with that idea when somebody else writes them for you. But I can tell you from past experience, when I ask students to write the unit test first, it feels very uncomfortable. It feels very unnatural. A lot of students want to write the code first, the functional code first, and then write all of the unit tests afterwards, showing that the code does what it's supposed to do. So I see this all the time, but I'm going to talk a lot today and actually show you today. We're going to write some unit tests, write some code today, talk about why writing the tests first might be a better idea. But first, let's just talk about some of the basics. So I just want to get some notes down on paper first, and then we'll actually actually do some coding. So let me just take some quick notes. We're talking about unit testing. First thing to keep in mind, what is the unit? So we're testing units of our that mean? What does it mean to test a unit of our code? And the answer is the unit can vary. What a unit actually is, the thing that's being tested can actually vary depending on my testing needs and the project that I'm working on. For our purposes in this class, we're going to keep things small. The thing we're testing uh, is a method. So our unit for the purposes of this class is a method. And because we're also very, very, very focused on object-oriented programming in this class, that means we need an object first. This will be very important later when we actually start writing. But it's important to keep in mind that even though we're using all these objects and different things, the thing that we're actually testing are methods. So the unit in unit testing is referring to a method in this case. When we're writing our unit tests, there are some properties that are important to keep in mind. The first property is that it should be fast. So our tests should be fast. People don't want to wait on slow tests. That's a simple fact. If a test is taking forever to run, it's going to make it more likely for people to just skip that test because it's taking forever to run. This actually goes nicely with another thing that we care about regarding our unit tests. I mean, another way to maybe interpret this, I'll add this on here. Another interpretation of this property, tests should be small. I don't want giant unit tests. I don't want unit tests that are going to be doing a lot of different things. I want unit tests to be focused. I want them to be focused on testing one particular situation. If there are lots of different situations that I'm interested in testing, then I will make lots of tests to test all those different situations. I don't want to do one test that's testing lots of different situations because that's going to be a very big, very difficult test to have to manage. Another important property is that unit tests should be independent. So what I mean by this, if I have 10 tests, say I've written 10 unit tests, I should be able to pick any one of those unit tests and run it by itself, and it should function independently. Contrast that to the opposite case, where sometimes, I've seen this happen before on homework assignments and such, sometimes the way that students approach the testing is, I'm going to run this test first, and if I don't run this test first, then the second test is going to fail, because there's something happening in the first test that is, setting up things for the second test. This is bad. This is actually very, very bad. That is a case where the test would not be considered independent. There should be no order for the unit tests to run in. The unit test should be able to run in any order and still test what they're supposed to test effectively. So if you find yourself in a situation where you say something like, oh yeah, this test will pass, but only if I run these other 9 tests first, that's an indication that your tests are not independent of one another, and you maybe need to revisit that test and rewrite it in such a way. When we do take a look at actual tests here in just a moment, I'll talk more about how we can ensure the independence of our unit tests. They should be self-validating. So what this means is tests are either true or false, or maybe a better way of saying it is pass, fail. The outcome of a test is either we pass the test or we fail the test. The outcome of a unit test is not going to be 7. The outcome of a unit test is not going to be hello, right? Those might be the outputs of some of the methods that we are testing, but the actual test itself needs to give me a definitive thumbs up or a definitive thumbs down. If there's any extra interpretation that needs to happen for the test results, right, after the test run, in order to understand whether the test passed or not, that's another indication that it's not a well-written unit test. We always want our tests to give us a clear and definitive, yes, this test passed, or no, this test did not pass. And then the last one, which is kind of what we're talking about today, at least in large part, is that they should be timely So that means that we want to write our tests first, and we also want to do it, write them around the same time as our functional code. So let's think back to, again, I've already made this point a couple times. I'm going to make it probably a couple more times before we're done here today. But let's imagine the alternate scenario where I write the functional code first, and then I come back later and I write a whole bunch of unit tests to pass that functional code. The disadvantages of doing it that way, I think you'll find, especially if you try this yourself, is that when I'm writing the test second, then the functional code that I'm writing may be harder to test because that code is not being written with tests in mind. When I start with testing first, then it forces me to think about the functional code in such a way that makes it easier to actually test and easier to demonstrate that, hey, this code does this thing. And I can prove it to you. I can show you by the fact that it passes these tests. So, really, I think what we're trying to accomplish with test-driven development is understanding that while the tests do serve a purpose, verifying functionality, they're also a tool for us that we can use to design our functional code and say certain facts about our functional code up front before we even write it. And that'll make writing that functional code that much easier because we've already made some of these important design decisions when we wrote our tests. And I hope that'll become a bit more clear once we take a look at some actual unit tests here in just a little bit. And so the last thing that I want to cover real quick before we hop in and start writing some tests and writing some code is the structure of a basic unit test. So all unit tests, at least in this class, there are variations that you may run into in other classes, but for this course, at least, all of our unit tests are going to follow the same basic three-step process. We're going to create the object, or it might be plural. We might need more than one object. Remember, we're testing methods, but since we're using object-oriented, all of them have to create an object first. That's pretty standard object-oriented programming advice. The second step is to call the method being tested. And then finally, the third step is to verify the results. And to verify the results, we're going to use something that you've probably seen before, but we're going to see a lot more. We're going to use something called assert verify. Right class, we're going to follow this basic three-step. With you next is actually start to work on a little project, a little program. I'm going to probably work on this project for a few different class periods between now and spring break. I'm trying to get you, we're kind of shifting closer to project mode. So I'm going to work on this project in much the same way that I'm expecting you to work on your project when the time comes for us to switch to project mode. I've already done this once, obviously, this morning for the first section of the class. So I already have a repository set up that I'm going to be using for this purpose. It's empty right now. I intentionally did not, save me a word from the first class because I knew I was going to have to do it all over again for you all. So right now, this is just an empty. You don't even need the repository, actually. If you're just trying to follow along with me for today, I would suggest that maybe a repository is perhaps a bit overkill, and instead what you could do is create a new Java project. In fact, why don't I just go ahead and do that now? I'm in VS Code, and depending on where you are in VS Code, you'll see here there's a button to create a new Java project, or you might be able to get there from no, it's not on the welcome screen either. So I guess clicking on the Explorer and then creating a new Java project, or is there a way to do it from here? There isn't a way to do it from the file menu, huh? Is that really the only way? Well, regardless of how you find it, we're going to create a new Java project. Build tools is actually a very important concept, but one that we have not talked about yet. Maybe we will a little bit later, but we're going to use no build tools. So that'll be what we select for that one. It now wants us to decide where to put this project. So I'm just going to go ahead and stick it in my documents folder. You are, of course, welcome to put it wherever you want on your machine. And then the last step that it's asking me for is to give this project a name. So the project that I'm going to make, the project that we're going to be working on for the rest of the day today, probably the next couple weeks, make a simple menu system. You've probably actually interacted with one of these things. I'm thinking of like the little Grubhub tablets, right, where you can order your lunch. I want to make a Java version of one of those programs. It's going to let me add my food items to an order and then tell me, you owe this much money. It's this much tax and all those fun kinds of things. So we're going to design a little food menu ordering system. It's meant to be a very simple program to give us some kind of, simple things that we can test. So here we go. I started my new Java project. And when I did, this is what Visual Studio gave me. It gave me a directory called lib, which we're actually going to need here in just a moment. But before we get to that one, I'm going to turn your attention to this source directory here. They gave us this app file by default, which I actually don't want. So I'm just going to go ahead and delete that. I don't need that, boilerplate Java code. But what I do want to take a moment to talk about is the structure of my project. So we're going to have two different kinds of code in this project now. We're going to have functional code, the code that actually does the stuff, does the thing. And then we're going to have tests. We're going to have code that shows that our functional code is working properly. And it's important to keep those two things separate and organized. So in my source directory here, I'm going to right-click this and create a new Java package. And I'm going to call the first one main. Main is typically what we use to indicate that that's where the functional code is going to go. And then I'm actually going to right-click the source folder again and make a second Java package. This time I'm going to call it test. So here's what it looks like once I've done both of those things. You can see that if I expand my source directory, I have one folder for main. That's where my functional code is going to go. And one folder for test. That's where my unit testing is going to go. And we're now ready to start doing some test-driven development. Test-driven development says the first step is to write a test that fails. So our goal is to write a unit test that fails. That might sound like a confusing goal or a strange goal. Then we're writing the test first. So the reason that the test is going to fail is likely because there is no functional code for it yet. Right? So after we write our unit test that fails, step 2 says, okay, go write the functional code to make that unit test pass. So test-driven development clearly states, first thing, write a test that fails, then write the functional code to pass that test. So let's talk about what kinds of tests, what kinds of things we should be testing. I'm going to try and start with easier things for us to test. The first thing that I want to test is I just want to make sure that it can properly track how many items are in my order. So can the order properly tell me how many things I have selected? Right? If I order a cheeseburger and fries and a drink, then it should tell me that there's 3 things on my order. Okay? So what I'm going to do, first off, is think a little bit about the design of this code. I've been talking about orders a lot, right? Been talking about orders a lot. The method that I'm considering writing this test for, telling me the number of items, is probably going to be in that order class. So the tests that I need to write are going to be for this order class, which I know doesn't exist yet. It will by the end of class today, I promise. But I'm going to right-click on my test package and select new file and just say order test.java. Consider that once I eventually get around to writing the functional code, that's going to be in a class. In fact, I could probably go ahead and make that now as well, since I'm on the topic. On the main package, I'm going to make a new file called order.java. And this does a good job of illustrating the structure of it. Like everything in the main, remember, that's our function code. That's the code that does stuff. Thing that's in the test is our test code, but it should always have this one-to-one relationship. Here's my order class. That means that I have a file called order test, and all of the tests for the order class are going to go inside of this test file. If and when I make a second class, which we will, if I want to test that second class, then I would make another file. All of the tests for that class are going to go in that second test file. There should be a direct one-to-one relationship between the classes that I have and the test files that I have. One class gets one test file, so on and so forth. All right, but we're not going to focus on the order just yet. We're going to focus on this order test. And this next step is actually one of the trickiest ones. I kind of botched it a little bit this morning. I'm not ashamed to admit which is basically making VS Code recognize that we are about to write some unit tests. Requires a little bit of work, requires a little bit of effort. So the first thing I'm going to do, actually, before I type anything here, is I'm going to click on the left-hand side. If your VS Code has all of the Java extensions installed, then you should see a little beaker over here on the left. If you don't have the Java extensions installed, then you might need to install them by searching for the extension pack for Java and installing that first. But assuming your VS Code has the extensions already installed and ready for you to use, when I click on this little testing menu over here, there's a button that says Enable Java Tests. So I'm going to click that button, and it gives us, these are 3 different types of tests that we can write. The one that I'm going to use in this class is the top one, JUnit Jupyter. The other ones are fine, right? There's nothing necessarily better or worse about them. This is just the one that I am most experienced with, so that's the one I'm going to stick with, is JUnit Jupyter. And when you do that, it actually adds this file into the lib directory. So prior to me enabling the Java test, this lib directory was empty, but now it actually has a file in it. That is the library that is going to allow us to run. That is the library that allows us to run unit tests. If this file did not appear in your lib directory, something went wrong. And as I said, we kind of struggled with this step a little bit this morning. So if you're struggling, don't feel too bad. It happens to all of us. The good news is that you only have to do this once per project. So once you get this set up and running, you shouldn't have to worry about it anymore, hopefully. And now that I have that done, I'm ready to start writing some tests. So in order for me to write some tests in here, I'm going to use what's called an annotation. Anything that starts with an @ sign in Java is known as an annotation. Annotations are not functional code. They do not do anything. They give clues to the compiler about how it should handle certain sections of code. So by using this annotation here, we're telling Java that when it looks at this code, it should interpret the method that I'm about to write, not as a regular, but as a unit test. So it actually will prevent me from running this method normally and keep me, the only way I'll be able to run the method that I'm about to write is as a unit test. So now that that's out of the way, we're going to make a method here. Unit tests are just methods themselves. Unit tests are methods themselves. They're always going to be public. They're always going to be void. As far as the name of our test goes, I almost always like to use a similar format. Test, and then the name of the method that we're testing. So the names might get a little bit long, but I want to test and make sure that an order can tell me how many items it has. So we're already kind of facing a decision here, right? What should that method be called? That method doesn't exist yet, right? We haven't written a method that can tell me how many items are on an order yet. But now we're already faced with a decision. What should that method be called? I think following, standard Java naming, that it's probably going to be called test get number of items or something along those lines. And now we're just going to do those 3 steps. I'm going to write out the steps first, and then I'll come back and fill them in. Step 1 is to create objects. It might just be one, or it might be more than one, depending on what you're testing, to be tested. The second step is to call the method being tested. So this method should be in the object that was created in the previous step, right? That's the implication there. Is that the method I'm testing is in this object that I'm creating in step 1. And then finally, step 3 is to verify. I can't spell today. Verify the results. All right. So the method. It's going to be in the object. Because that's the object that we're currently testing, even though, as I said, it doesn't exist yet. But let's start trying to fill these in. So the first thing I need to do is to create an order object. And this is where students start to feel a little bit uncomfortable. The order object doesn't exist. So how do I create an object if it doesn't exist? Well, we know how to call constructors, right? That is something that we know how to do. That's something we cover in the intro class. So we need to call a constructor here. And as we write out this line, the constructor, we're also going to make decisions about that constructor. So for example, this first part, I hope you realize doesn't matter so much. I'm just creating a variable there. This next part also pretty straightforward. The real question is, what parameters need to go in here? The biggest question we have. Does it need any parameters? So I'm trying to think about the order, making an order on one of those little kiosks, right? What kinds of instance variables would I expect it to have? Well, it's keeping track of the items that I'm ordering. So, but I don't know that that's really necessarily something we need to pass in as a parameter. In the morning class, somebody said maybe you could take in the person's name who's making the order. I actually think that's not a bad suggestion, right? So one argument would be that you need a parameter here to indicate the person's name. But I also think that leaving it empty is not a bad choice either. When it comes to design decisions, they're not always going to be a best choice and a worst choice. It more has to do with what your goals are. What am I trying to build? What am I trying to create? Just to keep things simple, I'm going to leave those parentheses empty for now and say that we don't actually need any parameters to our order constructor. If we find that that's not true later on, we can always come back and change that and update it. But for now, we need to make a decision, so that's the decision I'm going to make. So it's just going to have a very straightforward constructor with no additional parameters needed. Now we need to call the method that is being tested. So we know how to call methods on objects. This is something we cover in the intro class. So we start off with the name of the instance, which is test order dot, followed by the name of the method that we wish to call, which we already kind of made a decision about that, right? We said we were going to call it get number of items, followed by parentheses. Now, in my head, I'm thinking, well, this is probably going to tell me a number, right? It's going to give me 3 or 7 or, right? It's going to tell me the actual number of items, and I probably want to remember that. So I need to store it in a variable. And think about what we're doing here. Again, I just want to reiterate this point. This method, get number of items, does not exist. Actually, this is exists yet. We don't actually have any functional code. We have our tests. But I already know that this method can be called this. I already know that from the storing this value in the variable, that the return type of that method must be an int, right? So I'm using these tests to help me make these decisions. In other words, I'm saying this is how the object works. This is how I think this object, this method should work. And then when the time comes, we're getting closer to that point, I will actually make it work that way. But we have one more step to do before we can start writing some more functional code, which is to verify the results. We need to verify the results. So the results, the way that we do that is by using something called assertions. And there are a few different choices of assertions. So some of the common ones that you might see are assert true, which takes a Boolean value inside of the parentheses, or, assert false, which is the same thing, but the opposite. Or the one that I think I'm going to use is assert equals. Assert equals is a very common assertion to use. And it takes in in this case, it takes in two values. I have to say what I expect the result to be, and then I have to say what the result actually is. So the expected value is always probably just going to be some hard-coded number. I made an order. I make a brand new order. How many items are on that order? Heard somebody, yeah. 0, yeah, I think 0. I haven't added anything to the order yet, right? We haven't even made it that far. So I think this is an empty order. So I think the expected value should be 0. The actual value is the value that you get back from the method call. So the actual value is going to be items. This is our first unit test. You can see it does have some errors. Some of these we will fix when we actually write some code, but others just need some import statements. So this first annotation needs an import statement, if it'll let me pick it. Yeah, here we go. So I'm just going to use VS Code to help me with these imports. The assertion also needs an import statement, so I'll go ahead and have VS Code help me with that as well. Order also needs an import statement because it's coming from a different package. So we need 3 import statements to fix some of those mistakes. You'll notice that the last error that I can't fix right now is this one, saying that I have no idea what this method is. Well, it doesn't exist yet. We haven't written it yet. So that I'm actually okay with. If I tried to run this test right now, it would fail. Remember, that's the first step of test-driven development, is write a test that fails. So if I right-click the order test file and go down here to run tests, it very much is going to fail because it doesn't know this method doesn't exist yet, right? There is no method called that, so the test failed. The test is not going to pass. I got an error. But that's a good thing. That's what we're striving to do. So now we get to do the next step, which is to, write the code to make it pass. Let's write the code to make this test pass. So now I'm going to switch over to order.java, and I get to do some work here. First thing I need to do is I need to make the constructor and the instance variables. So for the instance variables, the only one that I think we absolutely need is some sort of a collection to keep track of all of the items that are going to be in our order. So I'm going to use an array list for that. I think an array list works very well. An array list of what, though, is kind of a complicated-ish question that we might need to think about. What am I actually storing in this list? I think you could make an argument for strings, right? So cheeseburger, French fries, right? The problem with only using strings here, though, is that eventually I'm going to want to say, hey, you owe me $12. But if all I have are the names of the food, how am I supposed to tell you that you owe me $12, right? So I need more than just a name. I need a name and a price, which to me suggests that, having just string here isn't enough, or having just double Maybe you want to use double for the price. Maybe that's your argument. Using double for the price, also not good enough. Maybe you would argue that I could have two array lists, right? One for the name and one for the price. I would argue that that is overcomplicating things. Let's use objects. It's Objects are free, objects are cheap, objects allow us to organize our code. So I think what we really need here is an array list of menu items. Well, what is a menu item? Well, we have to specify what that is next too. So, oh, I didn't do this right at all, actually. Private array list menu item items. There we go. That's the right way to do it. Where this is actually another class that we're going to have to create. Before we take that little detour though, let's import our ArrayList class to get that error to go away. And now we just have to deal with this problem where it says a menu item can't be resolved. Well, let's make a menu item now. New file, menu item.java. Notice that I put it in the main package. This is functional code, not test code. We'll talk about testing menu item in a little bit, but right now I'm going to finish what we're working on. So what does a menu item contain? It needs to contain those two pieces of information, the name of the food and how much it costs. So I'll make two instance variables for that. Here's a private string name and a private double price. I'm going to need a constructor for this. But the nice thing about this is that I think this is a pretty straightforward class. In fact, this class is in a category of classes called data classes. This class is really not doing anything more than just storing two pieces of information in a single unit, right? I don't expect there to be a whole lot of logic here or functional code here. It's really just a way of saying that a menu item has both a name and a price. That's really the sole reason why this class exists. So data classes are very common in Java. In fact, a lot of your tools, AI tools or whatever, will generate data classes for you automatically these days, which is a nice thing to be able to have. But I'm going to go ahead and finish up this data class by doing a very simple and straightforward constructor for it. I don't think we need anything else here right now. The only other things that I think that maybe you could argue needing in this class are getters and setters. And I agree that maybe at some point we will need to add getters and setters, but I never like to presume that we're going to need our getters and setters. So I'm going to keep moving, and if and when I reach a point where I can't proceed any further without having a getter or a setter, then I'll come back and add it in. But I don't just assume that automatically we're going to need those getters and setters. All right, that was a little detour, but back to the task at hand. Now we need to write the constructor for our order class. The nice thing is that we already know what that constructor needs to look like. We've decided there's no parameters for it, right? So we can come back here and make a no parameter constructor. We still do need to make sure that this instance variable gets initialized. Class, one of the things you get make sure that all of these instance variables have an appropriate value by the time the constructor is finished. For an array list or other type of collection, that usually just means calling the constructor for the array list. So items is equal to new array list, like so. This will be empty. I don't know if that comment is really necessary, but then. And we're almost there. We're almost ready to, check our tests to see if things work. It's not quite going to work yet because we still need to make one more method, which is the method that tells us how many items are in this order. But again, the good news is we've already made a bunch of decisions about that. We've decided what that method should be called in our test. We've also decided that it should have an int return type in our test. So that tells us all that we need to write the signature for this. we've also decided to, actually, I kind of glossed over this point, that it doesn't have any input parameters either. Because if it did, I should have included those in the test as well, but I didn't. And actually, this is going to be a pretty straightforward method. We'll just return items.size here to satisfy that. All right. I think we're ready to try our tests. Hopefully, if I did things properly, and it's possible that I made some mistakes, but hopefully, if everything goes well, the next time we run this test, it won't crash. It'll actually pass. So let's right-click Order Test and run the tests again and see that this time, yes, I got the green check mark, which means that this test passed. This test did, in fact, pass. So that's a great thing. That's a good thing. Are we done testing this method? Get number of items? Is this test enough to show that get number of items is going to work properly in all situations? Or are there other situations that that you think we should test to ensure the functionality of that method? Any ideas? Right now, we're only testing for the situation where the order is empty, which I think is important to test, right? But I think it's also important to test non-empty orders too. So I think that ideally we should have at least one more test for this method that has a non-empty that actually has some stuff in that order and still make sure they can properly tell us the total number of items. So let's write that test. Let's write that test next. Public. Oh wait, I forgot something. I forget this a lot too, and you probably will as well. Have to put at test. If you forget to put at test before the method that contains your unit test, it will not get run properly as a unit test. So I make that mistake all the time. Try to remind you so that you don't make that mistake as often as I do. All right, now test get number of items non-empty order. And you might be thinking, holy crap, that's the longest method name I've ever seen in my life. If that's the case, I mean, you ain't seen nothing yet. But I actually think that this is not. We're trying to be as explicit as possible about what we're testing. I would much rather have long, verbose names for things than the opposite. Short, concise names that don't give me enough information about what's going on. So if you're ever faced with that dilemma, right? Too much information is better than not enough information every time. The process is going to be the same. Create the objects, call the method being tested, and verify the results. In fact, we can probably just borrow some of the code from the previous tests, right? Create object. I don't need to write that all out again. I'll just do the actual code. So we definitely need this order. This time we want to add things to this order though, right? So that means I need a menu item. And I'll make a cheeseburger. So I've been talking about cheeseburgers. And we already have a constructor for menu item, so that's good. I can make a fake cheeseburger item by calling that menu item constructor, giving it a name of cheeseburger, and a price of $7.50. It's probably mad at me because we still need to import this. So let's use VS Code to fix the import for me, as it did. Okay, now that we have both an order and a menu item, I need to actually get this cheeseburger into the order, right? We don't have a way to do that yet. If I look at the order class, there is no way for it to accept a menu item and put it onto the list, but that seems like a pretty crucial piece of functionality, right? So let's use the test to help us understand what that should look like. I think that if I wanted to call a method to add the cheeseburger to this order, it would probably look something like this. Test order dot add item cheeseburger. Think about think about what this is telling us. The fact that I wrote this statement is telling us that, oh, I think there should be a method called add item, and that method should accept a menu item as its parameter. And since I'm not recording the results, the return type of that method is void. It's probably going to be void. So even just by writing this one line of code, we've actually made a bunch of design decisions about this add item method, which is what we're going to need to write here in just a second. But first, let's finish the rest of the test. So that was step one. Actually, all three of those were creating the objects, you're setting up your test situation, right? You're getting everything in place so that when you get to step two, which is calling the method, that it's in an appropriate testing position. You're going to get the results back that you're hoping to get back. So we're going to call the get number of items method. In fact, this line is just going to be exactly the same as before. So we can even copy paste that one. And then we're going to make our assertion. This time, however, we're expecting one. We're expecting one item. Oh, it's not assert true. I apologize. It's assert equals. There we go. So we've done it again. I wrote another unit test. This unit test is going to fail because this method doesn't exist yet. That's a good thing. That's what we're trying to do. I wrote a unit test. That test doesn't work. It's missing some functionality still. Well, okay, let's go in, and now that we've written this test that is going to fail, let's go in and add the missing functionality. So I need to create that add item method, public void add item with a menu item as its input parameter. And then we're probably just going to take that parameter and shove it into this array list that we have. So something like items.add mi should get the job done there. And now that I have added that missing chunk of code, hopefully, if we come back and run our order tests, we'll now see that we have two passing tests. Let's try it. Awesome. Yes. Now we have two passing tests instead of just one. Hopefully going through it a second time gives you a better feel for what this process is like. When you're setting up a project for the very, very, very first time, like I was the first round through, it is a bit more complicated. The test-driven development design is a little bit more complicated when you're just starting things out, when you're starting with a blank project with no code written yet. But once you have that basis and you're just adding things on, this is what it can really be like. Write a little bit of code. Add another test. Write a little bit of code to pass the test. Add a test. Write a little bit of code to pass the test. That's test-driven development in action. Writing our tests first, and then writing the code to pass the tests. We don't write any functional code until we have a test that can verify whether that functional code is going to work or not. So I'd like to do this again. I actually have a few other things that I definitely want to touch on, but I want to also just get a lot of practice. So let's think of another thing that we can test. I think that you could argue that there's more tests we could write for get number of items. What if I add three things to an order? Can it properly tell me that? But I'm going to move on to a different piece of functionality, which is the subtotal. If I have three things in my order, can it tell me the total, right? The total price of all three of those things on my order. So that's what I want to focus on next. Let's go back to the order test. There are at least a couple of different ways that I can think about approaching this, and actually it's similar to the test that we wrote. If I have an empty order, an order with no items on it, I would expect the total cost to be 0. And I think we should write a test for that. I think that's important to write a test for. And then similarly, if I have an order that has 3 items on it, well, I should, expect that it would properly sum up the prices of those 3 items and tell me the total. So I might actually write tests for both of those situations. excuse me, and then write the code that will pass those tests. That's another, I think, very important point. One that I will probably make again at the end of class today. Every method should have at least one unit test, but more is better. So you ideally want to cover all of the possible situations that you can conceive of, including what are called the edge cases, the cases where maybe you're not going to hit them all the time, but they're still going to happen. An empty order would be a classic example of one of those edge cases. Normally, we would expect an order to have lots of things in it, but sometimes it'll be empty, and we need to prepare for that case. All right. I forgot my test annotation again. Not surprised, but at least I remembered before it was too late. Let's make two tests this time. I'm going to make one test that computes the subtotal of an empty order and one test that computes the subtotal of a non-empty order. So they're going to look pretty similar, right? Test get subtotal empty order. So we need to create the order. This order is going to be empty, so we don't need any menu items this time. We just need to call the method that is being tested, which again doesn't exist yet, but that's okay. Let's think about how it would work if it did exist. When it does exist, I probably want to call a method that's called compute subtotal or something like that. And then that's going to probably return the value. So I would expect there to be a double that gets returned after I call that method. And then finally, I'll make an assertion that says the subtotal in this case should be 0. However, we do need to make one on the previous tests. Just looking at the number of items, that was an int. So ints are exact. If I'm talking about 1, that's clearly the value of 1. There's not going to be any fudge factor or any errors involved with integers. But with doubles are non-exact data types, which means that errors can occur. Errors are actually expected when you're using doubles. That's just part of the data type. That's just part of how the data type works. So when you're thinking about testing, especially when using doubles, you have to be careful. The chances that the subtotal will be exactly the expected answer is, pretty, well, it depends on what the value is, I suppose, but it could be pretty small because even a little rounding error somewhere along the way will make those values not match exactly. So when writing unit tests with doubles, if you're using doubles in particular, you have to include a third value with your assertion. And I'm using the wrong assertion type again, aren't I? I need to use assert equals. Sorry, I keep using the wrong type there. We need a third value when we use assert equals. This is the delta value, or you can think of it as the tolerance. I'm saying that as long as these values are within 0.05 of each other, for doubles, this is required. And if, you get to decide what the tolerance is. So if you want the tolerance to be very, very, very small, okay, that's fine. It's totally your choice to make. But there does have to be some wiggle room there. There does have to be some tolerance there. I think this is a good test for an empty order. Let's I'm just going to copy this whole thing actually and change it up. So test get subtotal oh no, don't do that. On a non-empty order will be our next task. That means I need at least one menu item. I might put 2 on there just to make sure that things are working properly. So I'll do a cheeseburger and I'll do fries. And fries will cost $3. We then need to add both of these to our test order. Cheeseburger, fries. There we go. And when it computes the subtotal for those two things, we're hoping that it gets the answer of 3 plus 750, which should be 1050. Oh no, did I change the wrong? I changed the wrong one. Ah, that's annoying. All of these lines should have gone down here. I'm annoyed at myself that I did that. There we go. Fixed it. So we have two very similar unit tests, but are testing for two different things. One with an empty order and one that has a cheeseburger and fries on it. Want to make sure it's computing that subtotal properly in both cases. So we've written two tests that fail this time. I actually think that's a good thing. You don't just have to write one test that fails. If you can think of multiple tests ahead of time, the more tests you can write ahead of time, the better, in my opinion. So the fact that we have two here is great. Honestly, if I had more time, I would actually probably make a third one, but I am a little bit worried about getting through everything with the time that we have left. So I'm going to keep moving, which means that I now need to implement this compute subtotal method. So the good news is we've already made decisions about it. Based on our tests, I can tell that this has no parameters and it's going to return a double. So, okay. That means I can type out the signature, public double compute subtotal with no parameters. And as far as the actual functionality goes, this is going to be a classic example of what's called the accumulator pattern. Even if you've never heard that term before, you've definitely written code that does this before. I am almost fairly certain. Whoops, not an int, a double. Double sum is equal to 0. I like to use a for each loop here, but if you would rather use the more traditional int I equals 0 loop, then that would also work. But I'm just going to iterate through my items array list. And now I want to say sum is plus equal to... Oh, well, here's a case where I need to retrieve... I missed, I accidentally a variable name. There we go. Fix my loop. This is where I would like to get the price, the menu item, and add it on to sum. Earlier, that I don't actually have any way of doing that yet. I haven't created any getters or any setters for my menu item. Well, now's the time. I've demonstrated a need. Here's where I need a getter, right? Right now. I wish I could do mi.getPrice, but that method doesn't exist. Well, okay. I know how to make getters. Let's do it. Public double get price, return price. And then I think the only thing that we need to do to wrap this up is to make sure to return our sum once we've finished adding up all of them. So the amount of code that I needed to write here, not very significant compared to maybe some of the past examples, but I believe it should get the job done. Let's run our tests and hopefully see that. All right, great. Now we have four tests that pass. If I were going to keep going on this, which I may actually do, maybe next Thursday or before spring break, it's very likely. So this project we'll keep working on some more. So we're gonna pick something to work on next. I'd probably focus on taxes. I don't really remember exactly how much tax is on food, but if it's like 7%, right? I would want a method called compute tax, and I want to make sure that if I have $10.50 worth of stuff, that it computes the tax properly. So I could write tests for that situation, and then make sure that it's actually computing the tax properly. Things like that would be where I would want to go next. But I would like to, with the 20 minutes that we have left, I would like to show you one more coding thing and then talk a little bit more generally about what kinds of things we should be testing to wrap things up for the day. Let's start by looking at our order tests and noticing that there's some duplication. In fact, I actually straight up copied and pasted one of the tests earlier, right? So there's lots of duplication of code. And in general, that's a red flag for programmers. We don't like duplicating code. In particular, that first step where I'm creating the objects tends to be where a lot of that duplicated code comes from. So the nice thing that we can do with that is actually abstract that part out. We can make a setup method that will create all of our objects for us and have that method run before each of our tests. So the idea is instead of doing that first on creating objects, each individual test, instead we'll make one method to do step one for us and then run that method over and over and over again every time that we need to set up a new test. This is a very, 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 very common technique. The way that we're going to do that is with another annotation. So the annotation that we need for this one is called before. The before annotation says the method, whatever method is associated with this annotation, I'm going to call for each unit. So it'll call this method run this, call this method this, call this method run this, call this method run fourth test. The nice thing about doing it this way is that by calling this method before each of our tests, we can ensure a nice even starting point for all of our unit tests. This is a great way of ensuring that our unit tests will remain independent of one another. So let's go ahead and make this method. I usually call it the setup method. And what we're going to do, instead of creating this inside of the test, I'm going to make an instance variable. And then I will call the constructor upon that instance variable inside of my setup method. By doing things this way, I now no longer need to do this line of code in any of my tests. So since we've abstracted this constructor out into our setup method and made an instance variable for it, I no longer need this line. 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 And I actually want to do the same thing for the menu items for cheeseburger and fries. I'm going to make some instance variables for those as well. Private menu item cheeseburger and private menu item fries. And I will construct both of those in my setup as well. So here's the constructor for cheeseburger. And then the constructor for fries is right here. I'll copy that up top. And that allows us to get rid of even more duplicated code from our tests. So now I can get rid of these lines too. So hopefully you can see that by just including this one basic setup method to create our objects for us, we actually haven't changed the functionality of these tests at all, right? It does look like we're skipping step one, but we're not. We're just using this method to do step one for all of our unit tests so that we don't actually have to do it directly in the unit tests themselves. This leads to a much cleaner design. We should definitely make sure, though, that after we refactor, that we run these tests and they still pass, which they do. They do still all pass. So even though I changed the code up, I made these instance variables and made this setup method, I did not actually change the functionality of these tests at all. They all still do exactly what they were testing before. It's just now my code is a little bit cleaner. Think about what this means for future tests. Happy order that exists. I can just use it directly. And I can also choose which items I want to add. If the test that I'm trying to run requires the order to have items in it, then I can go ahead and, use those inside of the actual test when I need to, like we do here. For this test, we decided we wanted a cheeseburger and fries, so I added them. For this test, we decided we didn't want anything in the order. We just wanted it to be empty. So I just jumped right to 6, which is calling the method being tested and then verify the results. Are there any questions on that part of it? So the last thing I want to chat with you about, the last thing I'm going to leave you with today, let's revisit this topic of what the heck are we testing? Because this is a common point of confusion on the project as well. So let's talk about what methods we should test. If you've been paying attention and following along with me today, you may have noticed that there's do not have tests. So not every method needs to be tested. We should be aiming to test as many methods as possible. So we always want to do as much testing as possible on as many methods as possible. That is our goal. But methods that we can't test, or maybe in some cases they can be tested, it's just very difficult to test. Let's start off with some that don't need to be tested. One example of a method that doesn't need to be tested is this one right here. Constructors. Constructors have kind of a formula to them, right? Constructors have a pretty straightforward approach for most of them that says, I take in parameters and assign them to instance variables, or I don't even necessarily need to take in parameters. Sometimes I just need to construct an instance variable. If that's what the constructor is doing, you do not need to test it. However, there are some cases in which constructors do need to be tested. Unless, so they don't need to be tested unless they are validating data. This is probably the number one reason why we do choose to test constructors. I'm not going to code it up for you right now. Maybe in a future class I will. But let me show you at least an example of a constructor that I would argue does need a test. This one. I didn't write any tests for this. If this was final code, I still wouldn't write it. That there is some additional functionality. For example, this price could never be negative, should never be negative, right? I should be validating the price that comes in, making sure for my instance that it is not negative. And if it is negative, that should be an error. That should be a problem. If your constructor is doing something like that, then you do need to have a unit test for it. You absolutely do need to test. So if your constructor is just using the simple, straightforward, formulaic approach, no unit testing necessary. But if there's additional validation or additional logic going on in your constructor, then yes, you do need to unit test. Simple getters and setters do not need to be tested. So what do I mean by a simple getter and setter? We wrote one earlier today. This guy is a simple getter. You learned this formula in the intro class, right? Or you've probably written a bajillion getter look like this. What I'm doing is returning an instance variable. I mean, it's too trivial to test. That is not something that is worth our energy and time to consider testing. So don't worry about it. Other times it may not be so straightforward. So, for example, this kind of looks like a getter, right? Uses that word get, but it's not returning an instance. It's more than that. I think people would argue that we don't need to test this one. It's kind of just using a getter from the array list. But it is a nice way to introduce you all to unit testing. I don't see any harm. I don't see any harm in having these unit tests. But yeah, be careful with those simple getters and setters. Other things to be aware of. with testing. Void methods are hard. We actually have one of those. This one. How do I test this method? It has no return value. There's nothing for me to actually kind of tested this method indirectly. When we added an item, we could verify that it worked by seeing that the number of items had gone up by. So even though we don't have an explicit test for it, uh, we still kind of indirectly test by checking the other ones, which to me is a good thing, right? So maybe I don't need to write specific tests for this because I know that this is working properly. That's a good thing as far as I'm concerned. But void methods come in many different shapes and forms. So one other category of void methods, it's kind of similar to a void method. UI methods. So by UI methods, what do I mean? I mean methods that display things to our users. That could be either just printing out a big old block of text, which is sometimes necessary, or if I'm doing a more professional user interface, buttons and windows, right? There might be some methods involved with dealing with all of those buttons and windows. Can you test UI methods? Yes, but it's difficult. It is difficult, and it's really kind of outside the scope of this class. So I am not going to ask you to write unit tests for any methods that are pure UI focused. That is not something that I'm interested in. I don't want to tell you that it's impossible because it's not. And if you are interested in UI stuff, I would encourage you to take a human computer interaction course where they will talk to you more about how to do UI testing and spend the amount of time on it that it deserves. I don't have enough time in this class to give it the attention that it deserves. So we're just not going to worry about it. I'm going to let Dr. Kelleher take care of that. Another category of methods that we don't need to write tests for are private methods. This one is a little bit trickier though, because sometimes these private methods are doing a lot of work. And if that's the case, if that method is doing a lot of work for me, I'm using it a lot, it's got a lot of logic in it, then I really want to test it. So it might be tempting to make it public so that you can test it. There are security implications with that. So it's this perpetual trade-off of easy to test versus secure. The more locked down something is, the harder it's going to be to test properly. I can't tell you, where that trade-off is when it becomes more valuable to make things public versus keeping them private. That depends on the project. That depends on your security concerns. There's a whole bunch of factors that go into that decision. But if a method is truly private and you aren't going to make it public, you don't want to consider making it public, then you can't test it. It still can be tested indirectly, right? So private methods can still be tested indirectly via getters and setters. My spelling is bad today. There we go. So we can still kind of test those indirectly via getters. The last thing that I want to leave you with that's going to be important kind of for Tuesday, but honestly more important for the project is small methods are easier to test than large ones. That's just a fact. That is just a plain, straight, simple fact. And one thing that I want you to notice with me doing this test-driven development exercise today, hopefully you notice that by following that test-driven development strategy, the actual code that I wrote, these methods are small. You might argue that they're not doing very much, but I would argue that that's a good thing. Our methods should be small. Methods that are large, methods that do lots of different things are going to be hard to test. classic example of this kind of ties back into what we were talking about on Tuesday with the files. If I have a method that reads in a bunch of stuff from the files and does a bunch of computations with the data all in one method, it's going to be very hard for me to test that method. I really need to keep the file stuff separate from the crunching numbers stuff so that I can test them independently of one. And that is a common thing that is definitely going to start tripping up a lot of people once we get to project time. But I would really highly encourage you to force yourself to try this test-driven development approach. I think, we're about to get into a whole unit where we talk about clean code, what it means for code to be not just functional, but also well-designed and well-written. One of the strongest arguments for test-driven development is that it forces you to write well-designed code, forces you to write small chunks of code. That's what we want. So it can really kind of get us to this, help us avoid the situation, which I see so many times, where students will write a big old chunk of code, try to test it, realize that it's impossible because the method is 100 lines long and it's doing 50 different things. Then they have to go back and figure out how to chunk it up into smaller methods and then test those smaller methods. That happens on the project every semester, and I guarantee it's going to happen to a group or 7 this semester as well. If you try the test-driven development approach, I think you'll find that it leads to naturally smaller methods. So we don't have that situation where I have to take this big giant method and break it up into small chunks. I'm just naturally writing those smaller, easier to test, well-crafted methods directly and skipping the whole part where I have to untangle the mess and figure out what I can test and how. So that's my speech in favor of test-driven development. You're going to get some practice doing some test-driven development on Tuesday when you come in for the next in-class homework assignment. But that's all for today. Let me know if you have any questions. Thanks for your participation today, and I will see you next week.